Namaste. This is assignment third on set theory and it is taken from discrete mathematics, and this is a short video project on 3 problems related to set theory, and it's me Daya Simkhada. Let me present the questions and the solutions of the set theories. And uh, as I said, there are 3 questions in these presentations. The first question is given by the construct an algebraic proof that is for all sets A and B, and A minus A intersection B equal to A minus B, and A intersection B union C equal to A intersection B union A intersection C. There are 2 parts in these questions, and let me prove the first part. And the first part, taking the first part, which is A minus A intersection B equal to A minus B, and for this let A and B be 2 sets, and we have to prove that A minus A intersection B equal to A minus B. So this left side is taken here, and we know that A minus A intersection B equal to A intersection B whole complement, and which is by the set difference law. And similarly, by the De Morgan law, we know that complement of A intersection B equal to union of their separate complements, which is A complement union B complement, and remaining as it is. And similarly, here it is here intersection is distributed over union, and so it can be written as A intersection A complement union A intersection B complement, and it is by the distributive law. And then we know that A intersection A complement is phi, this union as it is, and then A intersection B complement as it is. And then which is equal to A intersection B complement, because we know that phi union any set equal to that set, or the phi union P equal to P. That is the identity law of set operation. And then which is written as A minus B, which is the set difference law. And here we can say that taking from left, that is A minus A intersection B, we got the right, and which is A minus B. Suppose this relation is relation 1. And then again taking right hand side and try to find the left hand side from right hand side, then taking A minus B, then A minus B can be written as A intersection B complement. It is the by the definition of set difference law. And then we know that the phi union any set is that set itself, and so here phi is written. And then also we have phi is A intersection A complement, and then union A intersection B complement, and then it can be written as, and the first line is since intersection is distributed over union, and so by the distribution law it can be written A intersection A complement union B complement. Then it can be written as by the De Morgan law, A complement union B complement is the complement of A intersection B, A intersection as it is. Similarly, by the definition of set difference law, we can write A minus A intersection B. And that is, now we got the left side from the right side, and similarly from the relation first and second, the A minus A intersection B equal to A minus B, which is proved. In the second part of these questions, we have to prove that A intersection B union C equal to A intersection B union A intersection C. To prove this, let A, B, and C be sets. Then we have to prove that A intersection B union C equal to A intersection B union A intersection C. And if X and Y are sets and X equal to Y, if and only if for all X, X belongs to X, if and only if X belongs to Y. Using this property, first I will give a formal proof written as a series of double implication. X belongs to the left side of given relation, that is A intersection B union C. Then this is identically equal to x belongs to A and x belongs to B union C. It is by the definition of intersection. And this is equal to or identically equal to or if and only if x belongs to A and x belongs to B or x belongs to C. This is the definition of union, and which is equivalent to x belongs to A and x belongs to B, or x belongs to A and x belongs to C, which is the distributive of and over R, and which is identically equal to x belongs to A intersection B. We know that, and refers intersection and or refer and. That's why or as it is, and here A and C, which means A intersection C, that is by the definition of intersections, and which is equivalent to x belongs to A intersection B union A intersection C. It is by the definition of union, and which is identically equal to x belongs to A intersection B union C, identically equal to x belongs to A intersection B union A intersection C, or it is said to be x belongs to A intersection B union C if and only if x belongs to A intersection B union A intersection C. And so, by the definition of the set equality, this proves that the left side equal to right side, which is required to prove. And the next questions is for all sets A, B, and C, we have to prove this relation. Here, union is distributed over intersection. And to prove this, and given set A and B are two sets, and we have to prove this relation. And to prove this relation, we know that A equal to B if and only if A is a subset of B and B is a subset of A, or if two sets are subset to each other, or one is subset of other and other is also subset of one, then we can say that they are equal to each other. So using this axiom, and for that, uh, let us suppose x belongs to whole left hand side. Here x belongs to whole left hand side, and this gives us, or this implies that x belongs to A or x belongs to B intersection C. And x belongs to A means if x belongs to A, then x belongs to A intersection B and x belongs to A intersection C, because both of them will have the elements of A. And then similarly, this implies that x belongs to A union B intersection A union C. And likewise, if x belongs to B intersection C, this condition is taken here, then we can write x belongs to B and x belongs to C. And this implies that x belongs to A union B and x belongs to A intersection A union C. And this implies that x belongs to A union B intersection, here and refers intersection, and then x belongs to A union C. And then here we see that if x is belongs to left hand side, then x also belongs to right hand side. And so from these relations, we can say that left hand side is subset of right hand side. Suppose this is relation 1. Now, taking the right hand side and try to get the right hand side is a subset of left hand side. So to prove this, let us suppose x belongs to this condition, that is the A union B intersection A union C. Then we can write x belongs to A or B and x belongs to A or C. Here union stands for O, or and the intersection stands for end. Look here, and then this, and we know that if X belongs to A, then X belongs to A union B intersection C. And if X does not belongs to A, X does not belongs to A, then X belongs to B and X belongs to C. And this implies that X belongs to B intersection C, and this implies that X belongs to A union B intersection C, and which imply that, look here, we have supposed that X belongs to this whole terms, then and we found the result that X also belongs to this right side also. And that's why we can say that A union B intersection A union C is subset of A union B intersection C. Suppose this is relation 2. And from 1 and 2, we conclude that the these two sets must be equal because both of them are subset to each other. That is, left is subset of right and right is subset of left. So they must be equal each other. And now my next question is, third question is, prove that for all sets A and B, A union B complement equal to A complement intersection B complement, which is the De Morgan law of set theory. We have to prove this. To prove this, let X be an arbitrary element of the universe. Then X belongs to A union B complement. And if and only if X does not belong to A union B, this is the definition of belongs to. Similarly, this is identically equal to X belongs to A union B complement. It means if X does not belongs to A, then X belongs to A complement. Similar to that, it is by the definition of complement, and which is identically equal to X belongs to A complement and X belongs to B complement, and which is equal to if and only if X belongs to A or X does not belongs to B. X does not belongs to A or X does not belongs to B, which is by the definition of does not belongs to, and which is equal to if and only if X belongs to A complement or X belongs to B complement, and that is the definition of complement, and which is equal to if and only if X belongs to A complement intersection B complement. As we have supposed that X belongs to A union B whole complement, and as a result we found that X belongs to A complement intersection B complement, and due to if and only if sign, we can say that both of them must be equal. That is the complement of A union B complement, or the complement of A union B equal to the intersection of their separate complements, that is A complement intersection B complement. And in this way, this question can be proved. And thank you so much for uh, listening to me and watching my slides. Have a great time always. Thank you very much.